Guys, I'm starting to feel like a computer science teacher with all this just talking about theory and stuff. And the truth is that we're not here just to learn about some programming concepts. We're going to try to make a game. So let's get to that today. Today is the day, guys. So let's make it happen. And what is the one big difference between a game and a story or any other medium for that matter? See, normally when you're looking at a screen and you're doing something, you just consume that content. You don't put anything out, you know? So if there's a screen here and this is a person, normally the relationship only works like this. And most time when the screen is just putting out this information, you just take it in. Now, inside of a video game though, that relationship becomes a little bit more two-way. And so if this is a screen, it gets to be more like this, right? And so far, we're still just doing this. Today, we're gonna do this. And in order to do this right here, we need to make it so that the player can put something into that screen so that you guys can actually make something happen into that screen that can create a relationship between you and the program that we are creating, therefore making us a video game. And in order to do that, we need to talk about something called conditionals. What are conditionals? Well, conditionals follows the same kind of logic that humans have. So for instance, normally we make our decisions, we check if something is true or false, and then we make a decision based off of that. So if something is true, if a condition is true, right, then we do something based off of that. This is the basis of the human logic that the people that designed programming actually copied. You'll see every programming language have these things, these if statements that check to see if something's true, and then they do something based on whether or not that something is true. A good example of what this could be is like, if this product is a certain price, I will purchase it. If it's more expensive than that price, then I will not purchase it, right? It copies human decision making. So let's go into Unity and actually get started on this. Open up our script. Mono behavior is not working again. I've had to fix this every single time that I've loaded it. The way that I've been fixing it every single time is I simply make a new line, I save it, I close out of Visual Studio, then I wait till it compiles back inside of Unity, which is basically the translator doing that job that I was talking about earlier. It's called compiling. And then we just go over to where it says first script and we just double click it again. And then normally when it reloads in this scenario, you'll see mono behavior change color, and then everything changes back color, debug and log, and suddenly everything's working correctly. Something about Unity's compiler, I don't know exactly why the problem's happening. I just know that making a new line fixes it, and then I just get rid of the new line after it's fixed. Okay, so we're gonna erase everything again because we don't need to do all this. And we're going to do something pretty simple here. We're going to create something inside of start here to make it so that it is possible to take an input. Because the way that input works is it follows that same human logic that we were talking about earlier. If the player is pushing a button, if the player is moving the joystick, if the player types in something, if the player does this, then the game reacts in a certain way. So we can start checking on that with this conditional statement. Now, the way that we write this for Mr. Translator to understand the if, because we're telling Mr. Translator that if. We're saying, hey man, if this is happening, then do this, because he's still got to translate this if statement into machine code eventually as well. So we write down if, as simple as that. And then for that condition for him to check, we start a parentheses. Anything inside of this parentheses is that condition for him to do. And then we can simply go these curly braces right here. And anything inside these curly braces is what he'll do if whatever is inside these parentheses is true. Now, the thing that holds the value of true and false inside of C#, inside of almost every programming language that I know of at least, is a different type of variable that we call a boolean. It's either set to true or false, and that's it. That's all it is. So if we create a boolean up here, we write bool, and we'll just call it test bool for now, just to have a name on it, and we'll set it equal to true for now, right? We'll write down test bool on here, and just like before, when we were making the other variables, we simply write the type of variable, we give it a name, and then we can set the value if we want, and then the semicolon tells Mr. Translator that we're done with that line of code, that we're finished with this whole thing that started with bool. Then we're going to feed that into there, and so if this condition is true right here, if test bool is true, then whatever happens in this braces is going to happen. Then this happens, right? So we're going to do a quick debug.log just to test it and just to show you guys what I'm talking about, and let's get into Unity really quick. And you can see then this happens is in here. So that's all fine and dandy and all, but what's that have to do with player input? Well, let's show you really quick. Let's put some of these square braces right here, and let's go serialize field like we did in a previous video. This will make it so that the editor has access to this boolean, and which means that we can change its value from true to false if we want. So if we go back to Unity now, you'll see it once it compiles, once Mr. Translator finishes doing its job, Unity will then have access to that inside of our script right here. Serializing the field gives us access. You see test bool is here, and this checkbox is checked, meaning that it's true. If it's unchecked, it's false. And we can prove it because I just unchecked it, and then if I hit play, all of a sudden, then this happens doesn't appear. If I go back over here and I check this box when the game is back off, because I clicked off of the game again, then I hit play again, because the checkbox is checked, it goes back to then this happens. In other words, by moving around and checking this box on and off, we are basically able to create different forms of input in our system here. Here's where things get a little bit more interesting. We can actually do tests inside of our game over here. We can check to see if something's a boolean based off of a test. We can actually do the test to see if something's true or false. So going over here where something says it's just true right there, let's actually do something a little bit different. Let's just end it there, and we'll do a test in our start now. So instead of doing it that way, let's go ahead and create a string that says player action. And we'll just make a default string for it to be at first, so you guys can kind of see what I'm talking about. And we'll also serialize this field. Now, again, you're not supposed to fully understand what the serialized field is yet. You are supposed to understand what it does, which it gives us access to it inside of the Unity editor. Now, just to show you guys, if I hit this enter right here and serialize fields above this, the spaces do not matter because Mr. Translator gets to this symbol right here. He knows what serialized field does. He sees all these blank spaces and he goes, that stuff means nothing to me. And then he hits this string right here, and then he goes, okay, that's what I'm actually going to be serializing. So just to show you guys that's true, because some people like to format their code like this instead, I'm going to leave that above this string player action. So now we'll have access to that. Now, if we go into start underneath where our comment is, and we write test bool equals, and what we'll do here is we'll write player action, and we'll put down an equal sign here, and then another equal sign. And then we'll go ahead and write attack inside of here. And then we'll end this. This might look very unfamiliar to a lot of you guys. So this test boolean is simply a true or a false. If it's true, this thing works. If it's false, this thing doesn't work. In other words, if that checkbox is checked, this works. If that checkbox is not checked, this doesn't work. Nothing in these braces happens if it's false. This only happens if it's true. So when Mr. Translator is going through this, he goes, okay, they're saying a conditional. They only want me to do what's in these braces if whatever is inside these parentheses is true. Right? That's what Mr. Translator is thinking when he hits this if statement. Now, when he sees test bool, he sees what it is over here, but this is the last value that's set to it. So he goes, okay, this is what it is. It's a boolean. That's okay. That's what I want inside of here. I always check a true or a false to see if I should do something in this braces. Then he sees, okay, what's this test bool equivalent to? What's inside of this box? He goes and gets his true or false box out. He opens it up. He sees it's equivalent to player action. Okay, that's a string. And then he sees this equal sign. Now, normally when there's an equal sign, you're filling up the box, right? You're taking this string box and you're filling it up with something. That's not true in this case. Otherwise, if this was one equal sign, what would happen here, this attack would be getting set equivalent to this. This string attack would be getting put inside of our player box. So instead of default, we'd be replacing default, that string, with this string attack. But when you put a second equal sign there, Mr. Translator gets it. He sees the first equal sign and he sees the second equal sign. And if there's a space there, he'll actually think that you're just doing one equal sign. But if it's equals like this, two equal sign in a row, he understands that you're trying to do a comparison between two strings right here, you see? And it could be two integers or two other things. He knows that you're trying to compare this, the thing on the left side of the two equal sign, with the thing on the right side of the two equal sign. And he knows you're trying to see if they're the same thing. If they're the same thing, he'll return true. If they're different things, he'll return false. So if I save this and I hit the play button back inside of Unity, you see test bool is set to true right now. But if we go ahead and hit the play button and start happens, you'll see that no text is printed onto here. So you see, because it says default and it's supposed to check to see if this thing says attack, test bool is now false. So theoretically, if I go ahead and check this box and make it true again, this should pop up, right? Well, it doesn't, because that part of the script, the stuff inside of here, only runs when the game first starts. So you see here, this actually creates us a Boolean. You see even on there, it says bool string.operator. So that first word that is on there, that tells you what it's going to return you. It tells you what it's going to make when it solves all of this. So when player equals attack, it returns either a true or a false from that, which is a Boolean. Booleans are the true or false values. We might as well be returning false in this case. Interestingly enough, do we even need to have a variable for this test bool? And the answer is no. We could simply have player action equals attack in here, and that will create the Boolean for us. In fact, this is the normal way of doing things. So if we go ahead and erase this, and then we erase our test bool right here, we don't need those things because we can simply do the test inside of this right here. And it's actually easier to read because then we can see what we're doing as a test. So you saw equals on here. We can actually do something else other than equals, and that's does not equal. Right? Because whenever you do an exclamation point, equals does not. Inside of C# or most programming language for that matter, there's exclamation point. So when you do exclamation point equal sign, this is now checking to see if this thing is not equivalent, and it will return true if it's not equivalent. So if attack is not the same thing as default in this case, it will return true because it's not equal, and that's what it wants to see in this case. So Mr. Translator sees this, he goes, if these are not equivalent, then I run this. So if those things are not equivalent, so if default is not the same thing as attack in this case, we hit the play button and then this happens, which is great. So it does work. Okay, so how do we make this into a game? Well, the truth is inside of start, we cannot because it runs once. So it doesn't actually get in input if you think about it. In order to get input from us, we have to use something else that Unity has built into it, and that's called void update. See, the reason why we need void update instead of void start is because void start runs once when the game first starts running. And let me show you guys what I'm talking about. If we change this back to equals, it won't run when we first start, right? See, it doesn't start. But what happens if I go over here and I change this to attack? In that case, it does equal that. It should become true, and then this should print out. The problem is that start's already run. It ran when we first started the game, and it's never checking to see if this is true, if this is matching up again. But update runs every single frame of the game. You see how the game is running at 2,000 frames per second right now? Well, every one of those frames that happens, update runs. Update runs 2,000 times per second on my computer right now with how it's working. Now, different computers run at different speeds, but so you get different amounts of updates occurring, but you can have your input checked based off of that. So we go if player action equals attack, and then we do the curly braces right there, and then we do debug.log, then we can check update, and we'll change this, then we can check start, right? And let's put a comment on here to say everything in these braces, brackets, whatever you want to call them, is run every frame of the game, right? Let's go back into Unity. We'll go ahead and hit the play button and nothing happens. But if we write an attack here, all of a sudden we have a ton of messages going off on there. And if I actually just quit this game real quick, it's actually kind of hard because it's printing out so much stuff. You can see that it just keeps on printing out. Then we can check update. Now it's actually got a lot more updates than it can show on our screen here. Now, if I go ahead and do the same thing again, and I do it before we hit the play button. So if we change this attack before we hit the play button, and then I click off, you can see the first thing that happens, then we can check start, then we can check update happens. So you can see start happens first, guys. Okay, so I think you guys are getting it. We'll change this back to anything other than attack. We don't want it to be attack right off the bat. We'll clear this out. And then let's go back into Visual Studio. So this is where we're going to get a little bit more challenging. We're going to go ahead and get rid of this if player action equals attack. And the thing is, we only want the attack action to happen once, right? So go ahead and see if you guys can figure out a way to make it so that when we write an attack, it actually stops attacking right after we attack once. So it'll only display this message once. This is a challenge. Make it so that it only happens once. It'll display this message once, and then it's done. It stops displaying this message. Go ahead and see if you can figure out how to do that now. Alright, so this happens every frame of the game, but this only runs if this is true. So if we simply make it false, if we change what the player action variable is equivalent to, then we can fix this. So we simply go player action equals, and we can say I attacked or something like that. And then we get done with that and we go back over into Unity. We hit the play button and nothing should be printed. And then we write in attack over here and you see that then we can check update happens. If I click off of that box right there, you see I attack because player actions now actually equivalent to I attack, which is pretty cool, right? We were able to get kind of a input and a response from the thing. In other words, we kind of have a game going. Now the problem here is that we're not actually doing something with that. So this is where we're going to do a bigger challenge and we're going to start escalating things a bit here. So we're going to make some variables here. We're going to make an int enemy health and we'll set that equivalent to like say 10. Int player health, let's say 10. And we'll make an int player attack and let's set that equivalent to like, 2, and int enemy attack. Let's set that equivalent to 2 as well. All right. Now using these variables right here, go ahead and see if you can make it so that we can have a attack system happen where when you write attack, the player attack, and then the enemy attacks you back, and that we display that information inside the debug.log. And so basically you can win by just typing in attack continuously. Go ahead and see if you can do that now. You're going to try to make yourselves a little game here. Okay, so in order to make this happen, you can simply say the enemy appears or something like that. So we're going to do that inside of start. We're going to say debug.log and enemy appears, write attack to attack. Something like that, right? And then when you actually write in attack, we'll actually have that happen. So player attacks enemy and we'll write in plus player attack plus damage, right? Do debug.log enemy has, and then we need to update this too, right? So we'll actually go ahead and say enemy health equals enemy health minus player attack, right? And we'll write in enemy health here. Enemy attacks back for enemy attack damage debug.log player has, and then we'll do player health here. Now the problem is we haven't updated the player health and we want to do that right here, right? So we'll do player health equals player health minus enemy attack. Pretty good so far, right? And then we need to set the variable, the attack variable, so that is the player action variable, and we'll change that equivalent to attack finished, right? So we'll go ahead and go back into Unity. We'll hit the play button. We write attack and you see over here, and let's actually, if you take this window, you click on console over here and you left click and hold, you can move the console over and you can add it to where this game and everything is. We want it to be bigger so we can see more of the screen. So you see that we write attack to attack. We attack them for 2 damage. They attack us for 2 damage and we fight like that. We can simply erase finish exclamation point and do it again. If we click off, it'll happen again. And then we can just keep on going like so. And this is still incomplete because this game doesn't have an ending. It has no way of stopping. So let's go ahead and create a Boolean up here. Now I'm going to do this in a way that you guys could have done if you guys had used all the knowledge that you had available to you. This is not the ideal way of doing this. In fact, this whole thing is not ideal. This is more meant to teach people than it is to actually give people the best coding practices. But keep in mind, this stuff is still all the technical skills that you need to do things. This is more about learning the technicalities than it is to learn about philosophies on how to program and stuff. So I'm going to make a Boolean called the end, right? And we're going to set defaults to start off with. And so we're going to go ahead and set up if the end, and we'll do something based off of that happen. Now we're going to say another thing and say if not the end, and you guys might not have known that you can just put a not in front of that. In that case, you could have also done not equals to true, and that also works. Then you can take all of this, cut it, and then put it in here. Again, you guys might not have even realized that you can put an if statement in an if statement, but why wouldn't you be able to do that? And then, because now you know that you can put if statements inside of if statements, you can go ahead and do different things. If the end has happened, then you want to check to see whose health is low, right? So you can say if enemy health equal to 0, then we'll debug.log, enemy is vanquished, debug.log, player is triumphant. Yay! That's what we want. However, if the player health is equivalent to 0, then we'll debug.log, player is vanquished, and we'll write debug.log, what a pansy. Right? Now, we'll go over here to where it says if the end does not equal true, and we need to actually set up the end to be true at some point, right? And by the way, you could have also done equals false on this as well. And right here, after we do this health, we're going to say if enemy health equals 0, then we'll say the end equals true. We take that box, we fill it up with the true value. Remember, you can only fill this box, this Boolean box, this Boolean variable with either true or false. And then we go over here and we say if player health equals 0, then the end also equals true. Now here's the thing, we don't want these healths to change unless these things are not true over here. So if the player's health does not equal 0, then he can attack the enemy. Otherwise he can't attack the enemy. So if player health does not equal 0, then we can attack the enemy. We can't even attack the enemy unless his health is not equal to 0, right? Because if he's dead, how's he going to attack the enemy? He shouldn't be able to attack the enemy if he's dead. And that would have been a problem because he would have killed each other if we would have gone through the system and they both had equal attack and equal damage and they were attacking each other every phase, right? And the same thing for the player as well. So we'll say if player health does not equal 0, if enemy health does not equal 0 down here, then we'll do the same thing and then the player health can get knocked down because of that. So we'll do Control X or Command X for cut, and then Control V or Command V for paste, and then we've gone through this. Now this is very convoluted, it's hard to read through. It's not how exactly you want to do it, but it's how we're doing it for now. We go ahead and save, and then we hit the play button over here on Unity, and we're gonna hit the play button, and we're gonna open up our console, and then we'll simply attack finished, attack again, attack finished, right? Yeah. And here's what's interesting. If we just erase up to this F right here on finished, you notice it doesn't happen. If I hit backspace one more time, the attack goes off. So that space is a character. Attack with a space after it is not the same thing as attack without that space. Hit enter. Same thing if I lowercase this first letter, attack, or I put a space in front of that first letter as well. So if we have the lowercase, not equivalent, nothing happened. If I hit a capitalized letter inside of this first one, but I have a space right there, also not the same thing. It's only when the spaces are the same. Attack finish. And then we do the final attack and boom. Enemy is vanquished, player is triumphant. It just continuously goes off. Now we only want that to print once. So as the final challenge of this lesson, go ahead and see if you can make it so that only prints once. All right, so going back over here, we go back into where we're actually printing it out. And this is going to be true any time. When you want to control something, when you want to change something, you want to go to where it's actually happening. And so we only want things to actually print once. So we'll simply make a Boolean print once instead of the equivalent to false, right? And so far, nothing's printed once. And then we can simply go down over here. We can say if print once is not true, so not print once. And now you guys know that we can do this, as I just taught you when we were talking down there. And then we'll do things down here. We're going to take this brackets and we're going to take that out and we're going to put it over here, and then it'll auto format for us. Now if it didn't auto format, you can select everything that you want to tab over, and you can highlight it all, and you can simply hit tab, and that'll also work. Control Z undoes if you guys went ahead and did things with me there. So now if we haven't printed once, then it'll run this check right here to see if the end has occurred, and then we'll simply say print once equals true and print once equals true. In fact, if you really think about it, we really don't need to put it in both of these things. We can just put it down here because we want it to be true regardless of which message is put down. So as long as the end is true, then we print once, no problem. So what this does is it checks to see if print once is false, which it is at the beginning of the game. Then it checks to see if the end is true. If the end is true, then it'll run all this. But do we really want to have this many different checks? And the thing is, when you have these nested checks like this, you can simply go space and you can put an and here, and then you can see the end like this. We can take all of this baloney out. That's not actually going into the right spot, so we'll just take all these spaces out for a little bit. So I've reformatted the code. You didn't have to, it would have still worked. Mr. Translator understood. And now let's talk about what Mr. Translator does when he sees this. So what it does when it goes through this, he goes through this if statement, and then he checks to see what print once is. He finds out it's false. He fills that in. Now exclamation point simply reverses whatever is in front of it. So he goes, okay, though that's actually true. Is what he does, right? So that's okay. And then this and symbol means that the whatever's on the right hand side has to be true as well. Well, currently it's false, right? And so because this is true and this is false, this doesn't work. And symbol means that both things have to be true. So this automatically returns false. That's what Mr. Translator does in that scenario. Now, say for the sake of discussion that the end was true, what would happen here is this would return false because it hasn't happened yet, so it is false right now. And then this exclamation point right here negates and changes whatever's in front of it, so it automatically makes it into true instead. The and is true right now because I just did it for the sake of discussion, and because there's a true on the left and true on the right of this and symbol right here, these two ands, Mr. Translator goes, okay, so the whole thing is true. Because both sides are true, this whole thing is true. That's how Mr. Translator works in this scenario. But we'll go back to false and fix everything up, and now this system should run and it should only print once. Let's test it one more time, just because I don't feel like going through this whole thing again. Let's actually go 4 health and 4 health, so we don't have to deal with, you know, going through like 10 turns. We'll go open our console. It says right attack to the attack. We attack, then attack finished, and then we do it one more time, and the enemy's vanquished player is triumphant. If we erase this again, nothing happens because nothing becomes true, right? We've controlled the flow of the game. In other words, there is a beginning, middle, and end here. We've got a full-blown video game, guys. It sucks, but it exists, and that's what's important. We were able to program one. Now, I know that we jumped up leaps and bounds on this one, but I think we built up a solid foundation in the first, like, what was it, 3 videos there to kind of get to this point right here. Now, if you didn't fully understand this, I kind of recommend trying to build a system of your own. Try to go through and make something happen with just if statements like this. Now, this is not an ideal way of programming. We're going to introduce different concepts as this goes on and forward. But for now, this is all I really wanted to show you guys. There are a lot of different ways to do things with if statements. There are whole other comparisons that we can do. But this is the kind of the starting point. Once you get this kind of understanding down, we can build upon it. And that's how we're going to do things a lot inside this. We're going to lay down the foundation, put a brick down, put another brick down, put another brick down. And sometimes some of the bricks are going to fall down and we're going to have to pick them back up and put them back down so we can just build upon what we've done before. Anyways, hit that like button, do me a favor and subscribe, hit that bell notification. I have a Patreon down inside the description below if you wish to support the channel further, but it is in no way a requirement, guys. I'm so grateful for your time here, so much disproportionately more grateful for your time than I am for anything else. Thank you for spending this time for me. Thanks for hanging out. I hope that you guys have a great day. Bye.